I have got our next question on the screen. It is a bit of an easy start, the question, but as I warned you with the previous one, the end of this question is really a little bit more of a challenge. So let's not waste time. I'm going to go quick through the first two parts so that I can get to a third question if there's time, just to show you how to deal with those ratios. Okay, here they tell us that ABCD is a parallelogram. Now remember what I said? If you read something important, you stop and you fill the information on your diagram. What do we know about a parallelogram? We know opposite sides are parallel. We also know that opposite sides are equal. We know that opposite angles are equal. We know the diagonals of a parallelogram bisect each other, and at the point where they bisect one another, they form vertically opposite angles that are equal. We also know that there are corresponding or co-interior angles in a parallelogram. We also know that there are alternate angles in the parallelogram. A2C2 is an example. So there's a lot of geometry here, folks. By just reading that this is a parallelogram, I am going to color in my diagram. Don't leave your diagram clean in an exam. Once you start answering the questions, the answers should be on your diagram already. Okay, so let's have a look. This is a parallelogram, meaning that this side is indeed equal to that side, and that side is equal to this one. I've already indicated that they are indeed parallel. We also know that this angle here is equal to D1. Why is that so? Well, here's the parallel lines, and the diagonal forms the transversal. So those are alternate angles. Now the same for B2. B2, I'm going to just use a little circle. B2 is alternately equal to D2. C1, which I'm going to use a two-liner for, is equal to A1. If you run out of symbols, by the way, folks, just go and get yourself a set of colored pens. Just 5 or 6 or 7 colors. Then you can use different colors on your diagram instead of different symbols. Okay, there's one angle, the one I started with, that I didn't fill in, and that is that A2, now I'm going to give it 2 little ears there, is equal to C2 for the very same reason. Okay, now we know, now I'm not going to indicate this, but we need to remember this, that the length of BP is equal to the length of PD, and the length of AP is equal to the length of PC. The diagonals bisect one another. If I put in different lines to represent that on this diagram, the diagram is going to look horrific. Okay, so just remember that somewhere, file it so that if we need it, we can come back to it. Okay, then they say to us, points A and B are on the circle. Okay, diagonals AC and diagonal BD intersect one another at P. Now again, it's one of those points. Why did they make reference to it as a diagonal? Because they form vertically opposite angles that are equal to one another on this diagram. So let us mark P. I need a different symbol here, so I'm going to just give it a little bit of a wobble there. Those two are vertically opposite, equal to one another. And there's no marking here at P, so I'm not going to mark this way. That's a dead giveaway, by the way, matrix. If an angle is not marked, you most probably do not need that angle to answer the question. Okay, now just think why we do that. The end of the day, we mark over 200,000-300,000 papers. And if you have to look at an angle that's called BPC 300,000 times, trust me, it's not needed. If it's not marked, it's most probably not needed. Okay, let's read on. PD and PC intersect the circle. So PD, here's PD, and PC intersect the circle at S, or at R and at S respectively, they tell us. Okay. T is a point on AP. T is a point on this half diagonal AP such that, here's something important, TP is equal to PS. Now I'm going to use another color here so that we can see that clearly. It's going to be blue, so let me use orange. 1, 2, 3. 1, 2, 3. That's most probably going to become very important, that those two little pieces are equal to each other. Why am I saying that? Well, if you look at the whole diagonal, it's bisected at the point P. And from P to S on that diagonal, half of the diagonal is the same as from P to T on the second half. So already we can say that AT is equal to SC. We can bear that in mind. I'm just going to put a little cross on both of those to show that they are equal. Why can I say that? Well, this was equal to that. We know that that diagonal is equal to this one. Now, folks, can you see the diagram? It looks disgusting. That's what it should look like. It's a treasure map that helps you solve your problems. The last thing they tell us is that TR is drawn. This line from there to there is drawn in. Now, the first question, A, we are required to prove the following, that AT is equal to SC, and that's for 2 marks. AT, look at that. We've already got it on our diagram. How did we reason it? We said that AP is equal to PC, but TP is equal to PS, therefore AT is equal to SC for 2 marks. Okay, let's write the argument down as quick as we can. We're going to start by saying that AP is equal to PC, diagonals of a parallelogram bisect at P. Okay, that's the shorthand for parallelogram. So that means AP is equal to PC, but they told us PT is equal to PS. That was given to us, folks, and then we can just conclude that AT is equal to SC. Straight argument worth 2 marks. You've written enough for 2 marks. Don't go and write an essay. But these add to that, and therefore if I subtract this, and then that is left. No need for that. Okay, so let us go for the second part. The second part of the question says, we are required to prove again that triangle PSR is similar to triangle PBA. Now let's locate them. PSR is that little triangle there. PBA is the bigger one. Okay, that's interesting. So what do we have in those triangles? We have one angle that's equal to one angle. I would say that's somewhere that we can start, is stating those vertically opposite angles that are equal. So let's do that. P1 lies in the bigger triangle, and P2 lies in the bigger one, is equal, look at me, let me just move that up. P2 belongs there. Okay, let's get rid of let me just cut this and do it again. Okay, P2 belongs in the bigger triangle. Remember, that's important because you're going to read your ratios. So PSR, P3, PSR is first, is equal to P1. They are vertically opposite angles that are equal to one another because it's diagonals that intersect at the point P. Now we're in trouble. We don't know more. So let's go and let's look at our diagram and see where we've missed something. Have a look here. If you look at B, A, S, and R, it's 4 points on a circle, folks. It is a cyclic quad. It's 4 points on a circle. It is a cyclic quad. So now I'm going to try and see which theorems I can apply. Now let's have a look. If I look at angle S1 is subtended by the chord, the invisible, let's say the arc, AR, but AR also subtends B1. So guess what? This angle here is equal to that one. And by the same token, BS subtends R1 and BS subtends A2. So R1 is one of these bunny ears. Okay, they equal, and they both equal because of angles in the same segment. Okay, so I did not even need P. I could have just said R1 equals A2, S1 equals B1, big curly bracket, angles in same segment. But I've already started with P, so let's just join one of them. R1, now R is in PSR, so angle R1 is equal to angle A2 in the bigger one, and the reason, angles in the same segment. You almost did not see them. This rectangle is so overwhelming in this diagram with its diagonals going all over the show that you do not see that that little triangle there is part of a cyclic quad, BARS. Okay, so let's use that now and conclude. Our triangle PR, and the third one I didn't use is S, is similar to triangle PAB. And the reason again, equiangular. Those two are indeed equiangular to each other. Okay, now for the important one. They give us more information here, and they want us to use that information to prove something. Okay, so let me just go down a little bit. That's A, B, this is C. They tell us the following. They say if, given that PR over PA is equal to TR over AD, if that is the case, prove that. Now we've got two things to prove. The first thing they want us to prove is that triangle RPT is similar to triangle APD. Okay, that's the first thing we need to prove. But the information they gave us is what's important. They said that PR over PA is equal to TR over AD. Let's locate that in our diagram. Where's PR? PR lies over here. PR is right there. PA is this whole diagonal over there. So it's that part and this part over there. TR is this line that lies over here. And we've got AD, which is this full line here at the bottom. Okay, so, and that is exactly what they want us to show. APD, the big triangle, is similar to RPT, the smaller one. But based on the information that they gave us, they want us to prove that. And this is where the trick lies. Let's not waste time. I see I've just got over 5 minutes left. If I start with what they've given me, I'm going to change color. PR over PA is equal to TR over AD. And let's see, did we prove anything here? We've got a PR over there. Do we have a PA? Indeed, and you can see they correspond with one another there. Then if it's PR over PA, then that must equal any one of the two here which will correspond in our diagram. Okay, so we're using the first over the first. We now need to check, are we going to use RS or are we going to use PS? So I'm going to start and I'm just going to choose for us. I'm going to say, let's use PS over PB. That is equal to PS over PB. Now, folks, the question is, why did I choose that? Why did I not go for the RS, the other option? Let's look at the diagram. I know something about PS. I know that PS is equal here to this PT over here. Okay, I know something over there. And then I also know, so let me write this down. This here is coming from the similar triangles. The sides are in proportion. I can say that as my reason. But now I know the following. I know that that PS here is equal to PT. That's the first thing. And that PB is equal to, so PB here is equal to PD in the bigger triangle. Those are the diagonals that are bisected. So it makes perfect sense to have used PB in this case instead of the shorter side. I knew nothing about SR. Okay, so that would not have helped. Okay, let's have a look. So we can now say that from this here, but PS is equal to PT, that was given to us, and also we know that PB is equal to PD. Diagonals of a parallelogram bisect each other. And now it's just a matter of replacing those values in here. So we can immediately say that PR over RA is equal to TR over AD is equal to PS becomes PT and PB becomes PD. Now, folks, you can see there's PT in the smaller one and there's PD in the bigger one, and that's all I wanted to bring in. That's enough for me to conclude that triangle RPT is indeed similar to triangle APD, and the reason for that is the sides are in proportion. Now, this was difficult in the sense that you work with similarity most of the times by working with angles that are equal to each other. Here, we worked with a proportion. The proportions are in place, hence the triangles were indeed similar. Now, for the second part, a quick one, the second part, they ask us to prove that TRAD, let's go back quickly, TADR is a cyclic quad. Now, folks, from similarity, D2 became equal to the angle T1. Now, that's exterior to the quadrilateral, hence it's a cyclic quad. Okay, so all we need to say is that angle T1 is indeed equal to angle D2 from the similar triangles, and then finally we can conclude that it is indeed a cyclic quad, and the reason is exterior angle equals the opposite interior angle. Again, it's a converse. We're using converses here quite regularly in this proof. Now, folks, remember what I said. There's two tips here for you, and please take this to heart. The day before you write your second paper, you go to bed at 8 o'clock at night. Please don't go to bed at 1, 2 o'clock. You can see your brain needs to be fresh when you write geometry. You need to make, with your eyes, you need to make links in these diagrams. You read through that little paragraph that accompanies the rider or the problem in the exam, and you fill the diagram in, or the cues in on your diagram so that your eyes can pick them up. You don't have to go and reread things. The moment you've proved something, put the consequences on the diagram.